A very good morning. Morning. Welcome to our this one QUIZZIZ. All right, QUIZZIZ session covering from actually from 4 students. Okay, under chapter Forces and Motion, chapter 2. All right. So I believe our students have already done this. So I'm going to go through some of the answers, but I will not go through all. Okay. Like for example, look at question number 1. All right. You will see a car traveling at 20 meters per second accelerate uniformly. All right. For 8 seconds until its velocity reaches 36. What are the accelerations? So this type of question, you need to apply, the 4 formula of equation. Okay, let's write down what we know. All right. Okay, let's write down what we know. You are told that U equivalent to 20. Okay, let me write it down. And we're gonna have accelerate for 8 seconds. T equivalent to 8. All right, until its velocity V reaches 36. All right. What are the accelerations? So you know that you want to find A. All right, you need to find A for question part 1. Understood, you're going to use equation number 1. It's easy as that. If you are well aware of this, then easy for you to do. So it's going to be U plus AT equivalent to, all right, we're going to substitute the value 36 there. And the U is a 20. And understood, the A is what we are looking for with the 8 here. So understood, you're going to get a 8A equivalent to a 16 because it's going to be 36 minus 20. And your A will be a 2. So you have a choice of 2 there, but you have 2 answers. All right, it's either the first and the or the second one, okay, below. All right, so therefore we need to look for the next question. They ask for average velocity. So to find average velocity, you have to find distance traveled. All right, so probably you can do number 2, use equation number 2, which is S equivalent to U plus V over 2 times T. All right, this will be a direct one, which is equivalent to, I'm substituting the U 20 and the V is the 36 over 2. And I'm going to times with the time given there as a 8 seconds. So I will simplify this. I will get a 4. Then I'm going to get a 56 times with a 4. All right. You may not need to put the answer because it's not the end yet. All right. Question asking for average velocity. All right, average velocity, it will be total distance over total time. All right, so I'm going to push it higher. So, okay, total distance, we know is S over time given 8 seconds. So I'm going to put in the value 56 times with a 4 over 8 seconds. So we know, right, between 8 and 56. All right, we're going to simplify to have a 7, all right, after you divide it by 8. So understood, you're going to get a 7 times 8, okay, 28. So therefore, you'll be able to see, all right, the average velocity will be 28 meters per second, giving you the answer, all right, as your first one, okay? So you will be able to see, all right, acceleration is going to give you a 2, all right? Okay, and average velocity is going to give you 28. All right, do I make myself clear? So I make myself clear, we're going to go to the second one. All right, let's read the second one. Okay, this is a very direct question. This velocity decreases from 5 to 3 as he moves through a distance of 16. What is, okay, the deceleration? So we are going to use, okay, one of the 4 formula of equation. So allow me to go and erase, and I'm going to go to, this is going to be V, and this is going to be a U plus 2AS, okay? So I'm gonna, let me correct the writing. It was not properly written. V squared equivalent to U squared. So again, we're gonna write down what we know. All right, things like, okay, initial velocity is a 5. All right, okay, and final is going to be a 3 because decrease from 5 to 3. All right, and the distance traveled is a 16. What is this deceleration? Okay, that means us to find A. So it's very clear, all right? This is going to be a very simple and a direct one, all right? Okay, in order to find your answer there, you are going to use, all right, there's nothing to do with t, so we're going to take away the t. So take away the t, meaning you are not supposed to use the first, you are not supposed to use the second, all right? And you are not supposed to use the third one. So therefore, you are going to use the fourth one, which is going to be a, all right? Okay, I substitute straight away, 3 squared equivalent to u is going to be a 5 squared plus with 2 times with the a and a 16 there. All right, so I'm going to have understood, okay, it's going to be a 32a, all right, equivalent to 3 squared become a 9 minus a 25. So I'm going to get something like a negative, all right, 16, all right, negative 16, okay. Then I'm going to bring over the 32, so it's going to be negative 16 over 32, all right, okay. Negative 16 over 32. And if you press your calculator, you will probably get, okay, you know that 16 and 32, if you simplify, it's going to be 1 over 2. So therefore, you are going to get, okay, you're going to get 1 over 2, 0.5. But they're asking for deceleration. So you are going to take away, throw away the negative, and that's why your answer is the green button, 0.5 there. Is that clear, everybody? I think it's a very standard type of questions here. All right. So with that, I'm going to go to the next question. All right. This question, they're asking you what's the total displacement of the object when its acceleration is negative. Take a look at negative acceleration, meaning I'm going to ask you to focus on the negative acceleration. All right. Okay, and allow me to erase. All right, allow me to erase to get to be so that you'll be able to see the graph clearer. All right, okay, one moment. So I'm going to roughly draw the graph here. All right. So they are talking about negative, understood. Negative will be talking about this place. All right, it's not talking about AB. AB is positive acceleration. BC is zero acceleration. It's talking about D, E, not only that, until C to D, not only that, until E. All right, but you are given the number. All right, this is going to be giving you a 10. All right, if you look carefully, it's going to give you a 12 here. All right, okay, and this one is going to give you a 14. All right, okay, my drawing is not so accurate, but never mind, I try to improve on it. All right, until here, this is going to give you a 14. All right, I'm going to put a 14 here. All right, and this is going to be a 10 and a 12. All right, so you know you're going to do the first part. Okay, this is velocity against time. So in order to find displacement, you are going to use area. All right, so negative is talking about between C and D. C and E understood. All right, so negative. Okay, but we know we have positive from C to D actually is moving. Okay, if I were to draw it here, it's going to actually move. Okay, all right, the object is here. All right, it's going to move from C all the way to D. All right, it's going to reach here, and let's assume this is D. Clear? And how far is that? We will get the area. Easy job is a triangle. So distance from C to D, it will be the area. So I'm writing CD, okay, C to D. All right, that one I'm going to write again, okay, below because, okay, CD, huh? So I'm going to write, they write the formula, half times the height. All right, the height here is supposed to be a 10. All right, easy job, 10 times 2. All right, 10 times 2. Understood, we're going to cancel the 2, you're going to get a 10. You're going to get a positive 10, all right, because the graph is at the top positive. So in other words, it moves positive 10 meters to the right side. And you know it's going to come back, all right? Why? Why it come back? How do you know it come back? Because it's a negative area. Why negative area? Is below your x-axis. Clear? All right. So in other words, it's going to make a U-turn and then it's going to come back. All right. It's going to come back. And we know if the area is the same, it will come back to its place of origin here. All right. Place of origin, the one that I shaded in red. Clear? So understood. If I were to calculate distance between D and E, sure enough. All right. It will be area again, half times. All right. Okay. The height is 10, but it carry a negative 10. That means it is moving backwards. Okay. And a 2. Then again, we're going to cancel these 2. It will show you a negative 10. That means it go backwards. Okay. You go back to the original point. All right. It will actually go back to original point. Therefore, the displacement is going to be 0. All right. That's why the answer suggested here, all right, is a 0. Is that clear, people? All right, huh? So we're going to move on to the next one. This one, you have no choice. You're asked to find, all right, increasing order of distance traveled. You have no choice. You have to find the area one by one, okay? All right, your area one by one. If you do it carefully, you can still get the answer, all right? You get the answer and you will observe that you will get area for the first diagram is a triangle. Second diagram is a trapezium. The third one is also a trapezium. Arrange it, your answer is going to be PRQ. If it's too easy, I will not show to you. All right, the next one is number 5. Which one is true? All right, about the car over a period of time. This is a very direct one. If you were to take a look at the velocity, all right, you notice that velocity, all right, okay, at point A. And look at where the graph start, okay? I probably get my graph, all right? And I am going to draw a graph, all right? So that you'll be able to see what happened, okay? Okay, allow me to come up with my own graph. So I probably draw it here. You can see very clearly, all right, the velocity actually start from a number 15, all right, and it go up from point A, it go up until 35. All right, this is a 35. So it's very, very clear. If this is a 35, then understood it actually go up from 15 to 35. It go up by 20. All right, it go up by 20. And because it go up by 20, understood your answer is going to be, all right, the green button, the velocity of the car increases. All right, the velocity of the car increases by 20. All right, because you could see very clear the graph here show, all right, it actually increases from 15 to 35. Is that clear? All right, I think it's very clear, right? Okay, if it is very clear, I'm going to move to the next one. All right, I will not be talking about inertia. Question 6 is very direct. The same go to number 7. Okay, question already understood. The bigger mass has bigger inertia. All right, the same go to number 8. All right, they ask you which one has the highest momentum. You just multiply. All right, and the next one. All right, this is actually asked for impulse, change in momentum. All right, okay, if you are very clear about this, you should not be trapped. All right, because you know there is a positive and negative. All right, let's make the diagram bigger. All right, okay, and I'm going to use my, okay, to show you. Okay, it's very clear here. So the object with 1 kilogram, it is going to move to the right side. Okay, with initial velocity 2, and then it will bounce back. Okay, bounce back. Okay, how do I know bounce back? It moves in opposite direction. So this is going to be a V 1.5. So if they ask for change in momentum, meaning they're actually asking for impulse. So it's none other than, all right, MV minus MU. So what I always tell students is, of course, you're going to factorize to make your calculation easier. And what did I always tell you? You will take the V as positive. When you take your V as positive, understood, your U will carry a negative value. All right. So this is the value of the U. Okay. All right. So I'm going to put it in. The reason you can see very clearly, all right, is due to the fact All right, when the V is positive, you always get a positive answer. All right, V is a 1.5, then minus, I'm going to put a bracket there, or a close bracket with a -2 there. So there you go. You will be able to see actually 1.5 plus 2. All right, it's so clear there. All right, 1.5 plus 2, understood. All right, your answer will be 3.5. Okay, all right, boleh? Okay, so clear there. Okay, your answer is going to be if I were to add them up, it will be a 3.5. It's clear as that. All right. So there is no cause of concern about this question. Easy one. So let's not waste time. We go to number 10. Is an easy one. All right. And number 11. Okay. It is almost similar to, all right, the earlier question. Okay. Let's erase. All right. You are given two different masses. Okay. You are given two different masses. Okay. All right. You could see that at the top there. All right. If you were to say which of the following for both is the same? All right. At the top is two mass, 2m. At the bottom is 1m, but they are being pushed by the same force. You notice that if you read, pushed by the same force, right? Pushed by the same force continuously. So what I do is I'm going to put the same force here, F, all right, for the first, all right, and the second one. So instead of putting 2m, I'm going to put 2 kilogram at the top, and I'm going to put 1 kilogram at the bottom. Okay, so understood. When it is lighter, it will move with a high. Okay, when it is lighter, 1 kilogram, it will move with a higher velocity. So if this move with a higher velocity, it will be a 2, and this one move with a lower velocity. Why? Because it's heavier. All right, then it will be 1 meter per second. All right, so they ask you what is they going to be the same. Understood. Acceleration will not be different, will not be the same. All right, will be different. How do I know acceleration is going to be different? You all know this graph. All right, especially, okay, this graph, we are talking about A, all right, we are talking about A against M. All right, okay, A against M. When the mass of the object increases, understood, acceleration will decrease. So your acceleration cannot be the answer. All right, because the question is asking you which one is the same. Which of the following, look at that sentence at the bottom. Which of the following is the same for both? So acceleration cannot be the same because the mass is different. All right, so the best answer for you to be the same is not velocity. Okay, you see the third answer, the third choice, you notice the word, the increase in velocity, it cannot be. All right, also friction is out of the way. Increase in velocity, because the heavier mass 2 kilogram will have smaller velocity, 1 meter per second, but lighter mass 1 kilogram will have higher velocity. All right, but we know momentum will be the same, isn't it? All right, look at X is the first object and look at Y, the second object. Let's calculate the momentum of X. Understood, it's going to be mv. All right, so you multiply, you're going to have a 2 times 1. That will give it a 2 kilogram meter per second. All right, and we're going to do the same thing for momentum for the second object, which is the one at the bottom. All right, mv also, which is going to be, yes, 1 kilogram, but the velocity higher. So you'll get back the same number, okay, for momentum. That's why your answer is the first one, the first button, increase in momentum. Why they say increase? Because at the beginning, okay, the object are at rest. Clear? All right, at rest. So the momentum is 0 at the beginning, but both of them will have the same value or the same number for momentum, all right, when it's applied with the same force. All right, and as a result, the answer will be the first one. Okay, all right, and of course, the last question is based on the graph that I have given here. All right, you'll be able to see this graph. Acceleration against mass, it must be inversely proportional. All right, do you see that? Right, do you see that? Inversely proportional. All right. Okay, so the graph inversely proportional will be the graph for the last one. All right, because they changed the x-axis from m, they changed to 1 over m. So when they change the m to 1 over m for x-axis, it will become directly proportional. All right, with that, we will come to the end of this session. All right, okay, we will go to the second part of forces of motion. right? After you have done it, then I will come back and do correction with you all, okay? All the best to you. See you again, all right, in the next second part of forces and motion. Thank you.